Hello and welcome to a ramble about the last question of IEB November 2022's paper 1. Question 12, and it is not even a multi-part question, it's just boom, boom. No steps, no build up, nothing. Boom. So this should be fun. Below is the sketch of f prime x, okay? A and B lie on f prime x with C being the turning point. Okay, so let's just kind of digest what this means. And I mean, the very important thing is, to think about this, because most likely it's going to be a question where we're asked to discuss some aspect of f of x based on this graph, the graph of f prime x. So this is a graph that is describing how the gradient of f of x behaves, because f prime x is the gradient function of f of x. So for instance, and just a disclaimer, I'm going to refer to the gradient of f of x, the curve f of x, which isn't really very correct, because gradient is it's the steepness of a line segment between 2 points, at least as I understand it, whereas with a curve the gradient changes, inverted commas, the gradient changes from point to point. Really what we're talking about is the gradient of the tangent at that point. I think that's how I've always understood it. So anyway, when I talk about the gradient of the curve being what I really want to say is the gradient of the tangent to the curve at this point would be Anyway, so the point A has coordinates -1 and 54. So what this is telling us is that on the curve f of x, when x is equal to -1, the gradient at that point is 54. So the curve is very steep at that point, right? And here, when x is equal to 5, the gradient of the curve is again 54, so again very steep. And if we're to extend it a bit further, we can see that the curve f of x is always increasing, because the gradient values never go below the x-axis. They're never smaller than 0. So the gradient is either always positive, or at whatever the x coordinate of c is, at that x value, the gradient of the curve is 0. However, c is at a very significant point, because its y coordinate is 0, so that means f prime x is equal to 0. But also this is the turning point of this curve, which means that f double prime of x is equal to 0 at this x value, because that's where the turning point is occurring. So that means that this x value is where the original graph f has its point of inflection, because f double prime is equal to 0 there. Okay, so those are just some things that are coming up for me looking at this curve at this point. Right, c lies on the x-axis, and we've kind of spoken about the implications of that, but maybe let me just write them out. So at c, right, we know that f prime x is equal to 0, because c is on the x-axis, right? Its y coordinate is 0, or in other words, this function produces the value 0 at whatever the x coordinate of c is. So that's the first thing. But the second thing is also, we know that the first derivative of this guy is equal to 0 there as well, because that is where the turning point of this curve is occurring. And we know that turning points occur when the first derivative of the function is equal to 0. So the first derivative of this guy is this guy, which is actually the second derivative of f. So what it tells us about f is that at C, we have a point of inflection. Anyway, so the reason why we know that f double prime of x is equal to 0 there is because C is a turning point, right? Which means that, therefore, first derivative of f prime is equal to 0 there. Okay, so those are just some scribbles. Right, let's read some more. If f of 0 is negative 14, so the y-intercept of the original graph, f, is negative 14, and f of 2 is equal to 2, okay, so the point 2, 2 lies on the original graph as well. Calculate the x-intercept for f of x. So I'm going to try and maybe like draw a rough sketch of what this graph looks like. So we know that it's always increasing. We know that it has, its y-intercept is at negative 14, so somewhere down here. We know that, actually we can figure out the coordinates of C because they've given us these two. Wait, are we just assuming this is a parabola? I mean, if it quacks like a duck and it walks like a duck, then it is a duck. So we are assuming that this is in fact a parabola. So we can find at least, we can find the coordinates of C. We know that the y coordinate is 0 because C is on the x-axis. And then, this is maybe partly why they've given us these 2 points is they lie on the same horizontal line. Their y coordinates are the same, meaning that they are symmetry buddies, right? So the distance between them is 6 units. So from here to the axis of symmetry is 3 units, and from here to the axis of symmetry is 3 units. So this line over here, kind of made it look like a point, but this line over here is the x is equal to 2 line. 3 units away from 5, 3 units away from -1. So the x coordinate of C is 2. Just great. And we know that when x is equal to 2 on the original graph, the y coordinate is 2. So that is going to be the point of inflection for this curve. So it's going to be a graph that looks, it's going to inflect up there. So something like that, right? So this is a curve where, it is always increasing. And then the inflection is happening there. So our graph is going from being concave down to being concave up. Right. And what? And now what we want to figure out is the x coordinate, the x-intercept for f of x. Okay. So I mean, no, I don't know what I mean. So this is a cubic graph. F of x is ax cubed plus bx squared plus cx plus d. Okay, we have 2 points. So we have 2 points on it. We also know that f prime of 2, if we put 2 into this function, we get 0. And if we put 2 into the second derivative, we also get 0. So we can use that to figure out some of these constants, and that's probably all we're going to need. got 4 pieces of information, 4 unknowns, so that should get us through. So I'm going to start by using the first and second derivatives because there's no need for me to. So I'm just going to sub in. So I'm going to use the fact that, okay, f of 2 is equal to 2 to form my first equation. That is 8a plus 4b plus 2c plus d is equal to 2. So that's my first equation. Then my second equation, I'm going to use the fact of f, the fact that f of 0 is equal to negative 14. So that is actually going to get rid of a whole lot of my terms. So d is equal to negative 14. So in fact, I am going to take you guys down here. A little 2 that I'm missing there. And this will become my new number 1. Not really, I don't need it to be number 1. I can just replace the d over here. And over here, this can become 2 plus 14, which is 16. And we can simplify that actually. Divide through by 2, and we have 4a plus 2b plus c is equal to 8. And that can be my first equation. Okay, right. Let's move this up. Okay, then we said we're going to use the fact that, we're going to use the fact that when x is equal to 2, f prime of x is equal to 0. So first derivative, so we're looking at this equation over here, that expression. So that's 3ax squared plus 2bx plus c. Now, we know that when x is equal to 2, we get 0, right? So sub that in. So that's 3a times 4, 4b plus c is equal to 0. So that will be my second equation. And then lastly, we know that f double prime of 2 is also equal to 0. So firstly, we're going to figure out what f double prime is. So f double prime is 6ax plus 2b. Okay, so now we sub in the 2, and we know that that gives us 0. So that is 12a plus 2b is equal to 0. Divide through by 2. So that is 6a plus b is equal to 0. So those are our 3 equations, right? Equation number 1. Oh, did this thing just land up in a very weird place? Okay. Right, equation number 1. Equation number 2. And number 3. Okay, so first of all, of course, you know by now, if you've watched other videos of mine, that I am a fan of the elimination method. I can see that I can quickly eliminate my c's. So I'm going to minus, I say equation number 2 minus equation number 1. Okay, so that's going to be 8a. 4b minus 2b is 2b. The c's cancel out. And here we'll have 0 minus 8. I can divide through by 2 to get 4a plus b is equal to negative 4. So that's going to be my equation 4. And I can minus these two equations to get rid of my b. So I'm going to say equation 3 minus equation 4. So that's 6a plus b is equal to 0 minus 4a plus b is equal to negative 4. And that gives us 2a. The b's cancel. 0 minus minus 4 is 4. So then my a is 4 over 2, which is 2. And then from there, I can put it into either of these to get my b. So sub into, let's say, equation number 4. So 4 times 2 plus b is equal to negative 4. So that's 8 plus b. So b is equal to negative 4 minus 8, which is negative 12. And then sub that into, one of my OGs that has the c, let's say into 1. Okay, so we know that a is 2 and b is negative 12. And c is unknown. So 8 minus 24 plus c is equal to 8. We have an 8 on both sides, so those are going to cancel out. So c is 24. So in total, f of x is equal to 2x cubed minus 12x squared plus 24c, not 24c, 24x, and the d was negative 14, right? Yes, negative 14. Okay, and now what we want is the x-intercept. Oh, what a long walk to freedom. Okay, right, the x-intercept. Okay, we're gonna figure out where is this function equal to 0. Can divide through by 2. Okay, and from our diagram, we know that, okay, this x-intercept is going to occur somewhere between 0 and 2. So the first number I'm going to try is 1. So then we see 1 cubed minus 6 times 1 squared plus 12 times 1 minus 7. So that is 1 minus 6 plus 12 minus 7. 1 minus 6 is minus 5. 12 minus 7 is positive 5. So that does in fact give me 0. Happy me. This means that x cubed minus 6x, well, okay, what we're more concerned with is the original function. So f of x, which is 2x cubed minus 12x squared plus 24x minus 14 is equal to x minus 1, because that is one of the x-intercepts, right? Times something, and just for the sake of completion, we're going to figure out what the something is. So it's going to be times sorry to use, maybe let's not use the same letters. Let's say mx squared plus nx plus q, right? And I mean, if we do this whole multiplication, and I've shown this a couple of times, but you know, let's do a whole job of it. So if we do this multiplication, right, we get mx cubed, oops, we get nx squared, we get qx, we get minus mx squared, we get minus nx, and we get minus q, right? So the 2x cubed comes from one multiplication. It comes from this multiplication. The x squared term, the minus 12x squared term, comes from the x times nx and the minus 1 times mx squared, right? So that's where we get the minus 12x squared. The x term comes from two multiplications as well. It comes from the qx and it comes from the minus 1 times nx. And then the last term, the constant, just comes from this multiplication, minus 1 times q, right? So we can straight away tell then that this m over here must be a 2 because the 2x cubed came from x times that. So this over here is a 2. And also this over here must be a positive 14 because minus 1 times this is what gave us this term. So this is going to be a positive 14, right? So now we just need to figure out the little n. Okay, so at this point we have our 2x cubed, we have our minus 14, okay, we have, okay, x times nx, right? We still don't know what n is. We have x times 14, right? So this guy is actually 14x. Okay, we have this multiplication here, which is minus 2x squared. We have the minus 1 times nx, which we still don't know, and then the minus 1 times 14, which is that guy. Okay, but what we do know is that okay, we're meant to end up with 2x squared minus 12x squared plus 24x minus 14. Okay, so 14 minus something needs to give me 24. So this needs to be a plus 10x. So that means the n has to be a minus 10. Right, so if I have the minus 10, then I get a positive 10, and if I add those together I get the 24x. So n is minus 10, but let's double check. If we put minus 10 in here, does that addition work? So minus 10x squared minus 2x squared does in fact give us minus 12x squared. So we can confirm that n is indeed minus 10. Right, not that we needed all of that. I mean, we could just double check that we do in fact only get one x-intercept here. So we can just check for what values of x will 2x squared minus 10x plus 14 equal 0. So we can just check the discriminant really quickly because we already suspect that there aren't any real roots to this equation. So b squared minus 4ac, so that's 100 minus 4 times 14 is 56 times 2 is 112 negative 12, which is smaller than 0. So there are no real solutions to this equation. So indeed, the only x-intercept for f of x is when x is equal to 1. And that is that on that. Let's see what the memo says. And the memo does indeed agree that x is equal to 1. Sorry, burp. And just curious about the memo's approach, so I'm gonna try see if I understand. So they start by saying y is equal to a times x minus 2 cubed plus 2. Why? Where do these numbers come from? I am so confused. I don't even want to lie. I don't know what's going on here. Okay, the second one seems like I might maybe have a chance of understanding. So the second one starts by saying, okay, f prime x, so this curve, its equation is a times x minus 2 squared. So that's because the turning point has shifted from here relative to our original parabola, y is equal to ax squared. The turning point would have been here, but now it's occurring here at 2, 0. So that's how they get that equation, a times x minus 2 squared. Then they sub in one of the points. It looks like they sub in this point to find that a is equal to 6. So then they get the equation of this parabola using that. Then it looks like they do integration, huh? How do you get from f prime x? I mean, I guess it is sort of maybe easy enough to kind of eyeball it and work backwards from f prime to go back to f of x. But yeah, so I mean, that's a very valid approach indeed. I'm still curious about the first approach and how they knew that y is equal to a times x minus 2 cubed plus 2. How sway? I don't know. Okay, yeah, I think I'm gonna end my confusion here and reward myself with some well-deserved sleep. Thanks for tuning in, and yeah, see you next time as I face my arch nemesis, paper 2, and we have a bit of fun with that cool stuff.